Wow, this is blurry. I need my charger. And I'm gonna move this guy here. Wow, this is one shaky tripod. I thought I kept mine. Just when I need it. I can't find it. Oh my gosh, come on. This guy closer, so it's not shaking like ridiculously crazy, hopefully. Good Lord. Goal for 2025, actual camera equipment and OBS for shorts video, or for video live streams that aren't me sharing my screen. I doubt that'll happen, but hopefully it does. Wow, this is terrible. Alright, well, and this charger isn't going to reach, because why would it? So let me quickly explain what I'm doing right now, besides losing my mind. Hint, hint, wink, wink. I'm starting the assembly process for Ion Avionics, which is basically a flight computer I'm developing, and I'm no PCB design expert, that's for sure, but I do know that the first thing you do when you're starting PCB design is you start with proto boards. And so that's kind of what I'm doing here, is I'm just like building my first proto board, and essentially what that means is I'm taking all of the components that like I want to use on the finished product, and I'm finding them in breakout format so that I can prototype with them, get some code in, and just kind of figure some things out before I go to a final production PCB, which will be the end goal. But yeah, so today I'm just going to be doing some soldering, and hi, whoever's in the chat, hello. Yeah, so basically oops, let me flip this guy around, so show you what I have so far. Right now we have the Adafruit M4. Gosh, it seems like this is not focused well. So I've got the Adafruit Feather M4 board. The M4 is pretty cool. It's got an Atmega Atsum D51 chip. This chip is pretty decent chip. I think it's got like a 120 megahertz clock speed. I'm good. How are you? Oh, thanks for the like, Lily. I appreciate it. Yeah, I'm sorry. I'm like half monitoring the chat right now. So yeah. This is the Feather M4. This has got that Atsum chip I mentioned. It's a pretty powerful chip. It's a 64 pin MPU. This processor is pretty easy to pick up, and I chose this board because it's got nice power input, so I can do like a USB input or a battery input. And oh, thank you guys for the likes. I appreciate it. And yeah, I can do a battery input as well, and then I can add on things to this pinout area here. And then the other interesting thing is I bought this Adafruit triple expansion, so I can buy more Adafruit boards like that look similar to this, and these literally just pop into here, and I can buy more. I can put one here and here, and each one can have a different function. So it can be Bluetooth or some other wireless or a screen, pretty much anything I want I can put on here. Thanks guys, I appreciate it. But yeah, so that's kind of the idea, is that this is going to be expandable. Eventually I'll print a sled for this, so a sled that mounts this board when it's done. And right now, basically we're just working on power distribution. So for all these different sensors, taking our ground and positive and routing those guys all down to that main board right here. And then QC and shared IQC lines and like SPI stuff. But yeah, this is basically like just a kind of easy plug and play, prototyping, figuring things out, and going from there. Is my camera focused? I feel like it's like blurry or something, and I can't tell if it's just like a YouTube live stream thing or if I'm genuinely blind. Let's see. See, does it get better if I turn the light off overhead? Let's see if this helps. Nope, that definitely didn't. Okay, so let's get the soldering finally, and I believe I taped in. Oh wait, did I already do this one? Let's see. Yes. All right, so let's strip this positive wire, and then we're routing this positive wire that comes from this sensor here, or this SD card module here. This guy, you can see the second pin down, or the second pin up from the bottom is VCC. That's positive. So we're going to take that and we're going to route it to my shared positive bus, and that's going to run all the way up the board here. So let me strip this guy real quick. Basically just doing some basic power distribution right now, nothing too fancy. I'll get into it more probably on later streams today when I get to getting the flash chip and some other more complex hardware that I could not find breakout panels for. That'll be more intensive for electronics and whatnot, but here we are. So hard to see what the heck I'm doing. These tiny wires. Yeah, so gosh, I swear, I feel like this is blurry. How can I fix that? Like if I like tap here, does it focus? I don't know. Okay, let's grab some tweezers. Basically taking this wire right here, and we're gonna plug it into that hole, which I can't do because I'm blind, clearly. Oh, what the heck? Oh, I see what happened. Gosh. This is what I get for getting this really flexible silicone stuff. It really likes to do that to me. But yep, so if I can get this one wire in, then hopefully I won't lose my mind. Okay, I finally got that wire in. So now what we're gonna do is we're gonna flip the board over and we are going to solder on that positive wire. So I actually just ran out of flux, which is bad, or I mean solder wire, and we're gonna pick up some more. But yeah, we're gonna solder that positive wire on real quick. I got my fume extractor over to the left. You can't see it real well, but always want to make sure I try my best to not get lung cancer. So there's that guy. I'm gonna bridge these two together. So that's my first. And there. So yeah, that's done. Look, a whole lot, just 4 wires so far, but you can see positive coming up and the negative coming up from the spark fun. Oh, I'm sorry, the Adafruit board. And then that's getting split to all those sensors. And I actually bet now that if we take this, I bet if we take the spark fun board and we plug it in, that hopefully we should see the SD card module light up from the other side, just to do a quick test. I'm trying to remember, I believe the SD card module did have a light on it. You probably won't see too well, but let's gosh, I don't know, does this take in 5 volts? I'm scared to plug this in. I don't know, I don't want to ruin it. I'll just do the battery. Yeah, I bought this like charger. I was at Micro Center today, which by the way, if you haven't been to Micro Center, like, you gotta go. It's like heaven on earth for nerds. But yeah, so this is like the smallest battery charger I think I've ever purchased in my freaking life. It's like literally, I don't even think it's like an inch squared. It's pretty funny. But yeah, so let's plug in this battery here real quick, and we're gonna see if the SD card module is receiving power or if the magic smoke comes out. And I'm really hoping that it's not not the second option. So let's plug it in here. We got that. We got power on Spark Fun board. Let's see. Get out here. If I flip this guy over, am I getting power in here or not? Oh. VCC and ground. Well, oh yeah, Dill Pickle. Magic Smoke is really hard to put back in. Really hard to put back in. I hate the Magic Smoke, and I'm hoping we don't see it. I think that the SD card module does not have a light and that I'm freaking stupid. So I'm gonna pull this guy. Okay, the other thing, I don't know if anybody knows this or not. Probably do, but let me pull this charger again. Wait, actually, where did I put that charger? Oh, wait, here. This charger that I bought for this freaking LiPo was the dumbest idea or dumbest purchase I have ever made in my life. This charger is literally a 100 milliamp hour charger. This battery is a 2500 milliamp hour battery. This thing takes like a millennia to charge. So I was like, oh, I don't want to spend $15 for a 1S LiPo charger. I'll just get the 650 one. And then I'm like, oh, that was stupid. So, yeah, I mean, this thing is literally like, it's so tiny. It's hilarious. But yeah, let's like plug this back in, and hopefully it's done charging by the time I'm done building the board. So I think what I want to do now is route my power to the barometer because I think the barometer has an LED, which, yeah, okay. I don't know if you can see with this, like, freaking 140p video here, but this guy right here, that third one, I am like 60% sure is an LED. It could be a resistor, but I don't think it is. I think it's an LED. So let's get power to that because I want to make sure this thing actually is getting power and I'm not stupid. All right, quick question for the chat here, for our like few people watching. Is this video blurry? Because on my end, it looks pretty blurry on my phone, and I'm like kind of not happy with it. I've tried like focusing the camera, and it doesn't do anything. Like I don't know. Like, to me, this looks like so blurry on my screen, but maybe it's streaming better. I don't know. I still think this is better than freaking OBS Studio, though. Like, I swear, I have no idea. Like, I think I'm just cursed with OBS Studio. I really do. Like, I can never get a successful stream from OBS because there's always like, there's always something, man. There's always something. I can't. Okay, so yeah, let's flip this board over. Basically, what we're gonna do right now is, if you look at this guy, they didn't actually mark it on both sides. If I flip this over, you can see the markings for where these wires are gonna go. So we've got positive at the top, ground right underneath, and we've got our I2C lines, so serial clock, SDA, and then you actually, what's cool, not about this chip actually, but with the accelerometer, you can actually configure the accelerometer with either SPI or I2C. So you can utilize the SDL and SDA pins, or you can use your chip select and like SDO stuff, which I think is pretty cool that they include that option. And that's actually something a lot of manufacturers do with these parts. So like, here's your accelerometer right here, this black rectangle. It's a lot of these guys design them so that if you want to use it over serial, you can, or you can use I2C. It's really kind of user preference and like what's best for your project. So for my project, I want a mix of both, right? Like I want to optimize stuff. Like the I2C is nice because I can share, they all share an SCL and SDA together, so that's less wiring, if that makes sense. And then I would use SPI for or serial or whatever for my SD card and my my flash chip and other data logging stuff. So that's kind of cool because there's not a lot of pinouts from this main processor. I think a lot of them probably go to this like grid over here, but there's definitely more pins accessible to this because this is literally a 64-pin MPU. But yeah, sorry for the rant. That's like kind of the gist of what I'm doing. Let's see. I can make out pinholes and capacitors. It's not perfect, but yeah, I don't know. I haven't done a YouTube short live stream, so it's kind of the first time. But they kept showing up on my shorts feed, and I'm like, I don't remember this being a thing, so let's try it out. So yep, let's cut some ground, some black wire for grounding, and let's ground the barometer and see if that works, because I'm a little worried that I might be slightly stupid. But who knows? Aren't we all? No, honestly, it's kind of just a me problem. Let's see. Go here. I actually have no idea how I'm functioning right now. I stayed up last night until like friggin' 3:15 a.m. watching the stupid New Glenn launch because Jeff Bezos is like actually dumb and can't launch a rocket. Clearly, I could build New Glenn in a day, and stinky Bezos, I'm not ordering from Amazon again. It's not like 99% of these components came from Amazon because, you know, that would be preposterous. Um, oh, I'm actually so stupid. Why did I cut that so short? I have to pull the ground from here to here, and my friggin' goofy brain decided to cut a wire like half an inch long, so I can't actually friggin'. Uh, all right, let's cut another one. I really recommend this stuff. I don't know if you guys have ever. It's from like, I got this from Amazon. It's like Plusivo or whatever it's called. It's like nylon wire, I think. Why I like it is it's so quick for prototyping and stuff. Like, and just wiring in general. Like, you don't need wire strippers for this. You literally just can use your fingers, and it comes right off. And it's still like it's still strong, still durable. But I don't really need wire strippers, which is cool. Obviously, to cut some of these bristles down, yeah, I might. But like, for the most part, it just makes like building stuff so much easier to not have to like continually like repeat that process. It's one less thing to do. But yeah, so let's plug. We're gonna put this ground wire right here, coming up from here, and we're gonna route it to that pin right there. So we're gonna go ground here. And then one thing I like to do is to make sure that, like, this wire doesn't slide out and I don't have like exposed bristles on this side that could short out against here, is I like to take a piece of tape and like tape this guy down before I flip it over. So usually I'll just take like a small piece of masking tape like this, and just enough to hold it there, and then I'll take it off afterwards. That usually does a trick. So, gosh, I wish I stopped soldering and catted a freaking sled, because these two boards wiggling around is literally driving me insane right now. Um, like, actually insane. So, yeah, you got to get that rosin core solder, guys. Uh, this is ground right here. Did I ever tell you guys about my first incident with the magic smoke? Like, my first time seeing it? It was amazing. It was quite the experience. The magic smoke, it's quite mystical, I'll say. Um, yeah, so like probably like during COVID, so like right after finishing 8th grade, I had this like remote control Camaro, and I was obsessed with this thing. Like, I don't even know why I liked it. It was like this cheap little car. Um, but yeah, so like, goofy me decided to like smack it with a bat when I was like 6, and I was really distraught because I'm like, oh no, I just broke my favorite car, shocker. And so I screwed up the gearbox on the servo, and then like slowly other stuff started to go wrong, and I'm like, oh, this sucks. I don't want to get rid of it. So I finally took it apart one day. Right, like this was right when I got a soldering iron, by the way. So hopefully this clears some things up. But yeah, so like I'm like, oh yeah, I can fix it. So the like original cheapo speed controller on this thing was it was actually pretty poorly designed, now that I'm looking at it, and I'm like less stupid than I was. But that doesn't make an excuse for me to think that, oh, well, if that MOSFET fried, that means let me flip wires around and connect it to other contacts, because maybe wiring it the wrong way will fix it, because that makes sense to an 8th grader, right? So I maybe did that, and I put the shell back on it, which is like also another mistake. And like, this thing literally looked like a friggin' drift car. Like, as soon as I turned it on, shocker, like all this smoke came like flowing out underneath the frame of the car, like, and for like a split second I'm like, whoa, that's sick, and then I'm like, oh shoot, I am so dumb. So I maybe or maybe not, um, still have that circuit board, and I friggin' hung it on my wall to remind me to not be a dumbass again. um, and from then I actually like learned a little bit about wiring and not being stupid, but I'm still not that great, as you may be able to tell. Um, Gosh, I feel like this gauge is like just barely too thick for this board. Like, what is this, 22? I forget. I think this is 22. Like when I twist these leads together, they've got to be like absolutely perfect to go through the hole, which is cool, but it's so annoying. I might switch to like 24 next time. Oh boy. Gosh, I'm going to take this accelerometer off real quick because it's getting in my way. Let's see. So, like, if you ever want to get into, like, PCB design and wiring and electrical stuff, which, you know, obviously I'm still working on, I'm still getting into. It's not like I'm actually to the point where I'm making my own PCBs, which, boy, I want to be there, and I'm working hard to get there. But yeah, my advice is if you want to get there, start simple. It's really overwhelming. That's one of the reasons why I waited so long to start this project, is because I just didn't know where to start. And my advice is just like figure out what you want your thing to do, whatever it is. So like for me, I'm building a rocket. I want it to record X, Y, and Z in terms of data. I'm making this up. This isn't literal. And I figured out like generally what I want it to do. Obviously, you're not going to know like absolutely everything you want a board to do from the very start. But if you can figure out generally what you want your board to do, look from there, look for components. And I'm about to say like the cringiest thing possible here, but like if you're really trying to find like components that work for a project, ChatGPT is like actually really freaking good at generating a list of like computer components or something. Now, obviously, I do not ask ChatGPT to like make you a schematic. It's not going to be right. Like I guarantee it. That work you're going to have to do yourself. But ask it like, okay, this is my project. Name me a list of components that would work for this scenario, and then from there, hop on a forum or two, compare and contrast them. For me, sometimes there's gonna be like components that are better performance wise but have way less documentation, and you can't find like a breakout board if you want to do a proto board with them, which is fine. Like, I'm just saying, choose your boards on something you think will be easy to proto board with, and then eventually scale up to the point where like you're gonna make that PCB, and you're probably gonna make changes between the time like when you start and get to a final PCB anyway. So yeah, so we just got our ground wire on that guy, and now I'm about to cut the positive and get that on, and then fingers crossed this will work. Maybe a breakout board could be a good. Yeah, breakout boards are great. Another way is breadboards. You probably know what this is, but this is what a breadboard looks like right here. This is like gutted after Aurora. I use this for prototyping my Launchpad interface, and it just like it helps you get something in existence. That's just the hardest part, is it's like, how do you get something to like manifest, I guess, from it, like something to come into being, I guess. It's really hard. Like it is overwhelming. I totally get it, which is kind of why I sat back on this so long. But yeah, I'd say like a breakout board like this kind of thing, like breakout proto board type stuff. Oops. Also, let me move this. Or like breadboards. Either of those work really well. I I kind of knew a little bit going into this, so that's why I went to proto boards. If you need to like move stuff around and you're like really unsure where to put stuff, I'd actually start with a breadboard because you can literally pick up those DuPont pins and put them around where you need to. Versus this, it is a real nightmare to like have to unsolder a whole row of these headers or to like move stuff around. It's really difficult sometimes. So I would say like probably in order of how I would do it if you've never done this before is I'd start with a breadboard. I'd move to a proto board like this, and I'd probably do a few proto boards, change out some components, do some test code, and then I'd start messing with like actually ordering components. And before I'd actually solder the first PCB, what I would do is I'd see if you can find like a kit online or and this might be trickier for like non-rocketry applications because like in rocketry you can buy like computers that literally have nothing soldered on them, and you have to like solder on all of those tiny little capacitors and transistors and all that stuff. So like find something similar to like that concept where you have to practice soldering really small components because like you can't use an iron for like a lot of this stuff. Like there's literally no way, even with like the smallest tip I can find on the internet, that I could like solder these tiny capacitors without totally screwing them up. So like practice with solder paste and templates and stuff, because you'll find that like methods of soldering, depending on what you're soldering, definitely change. So that's my rant on prototyping computers at this scale at least. But it's a cool project too. The person I'm actually working, like I'm building the board, I'm designing it. I met somebody who is like really into programming, and I told him about like this project and how I would like to fly it Mach 3 on a build, like really friggin' high. And he was like totally hooked. He was like, yep, this is really cool. And he wanted to help me develop kind of some software, program it, and all that stuff. And that's kind of how that's going. I'm like so thankful that I met this guy because there's no way I'd be able to do that stuff myself. Programming is like for sure my biggest weakness. I can do it. Like if you look at some of my projects, like I can do it. It just takes me a while to figure stuff out. It's not my strong suit. So like the ability, like I guess having access to like or knowing somebody that like really likes this stuff and is totally willing to do this like and work with you is like I can't explain to you how thankful I am because it is really freaking cool. Yep. So that's kind of that. So we just got our positive on. It doesn't appear to be touching anything else, so that's good. Let's flip this over. And now if I pull this guy, I should be able to strip it off at the end. Okay, so that guy is set, and we're going to plug him in right here. This is going to get confusing really fast because I cannot see this. It's not because I'm blind. Well, maybe it is, but it's kind of because I'm in a friggin' basement, and I swear, like, no matter how many freaking lights I buy, it's always dark as heck down here, and I cannot see what I'm doing. I need like a 20 bajillion lumen light. That's what I need. I'm gonna put that on my Amazon wish list there. 20 bajillion lumen light. Okie doke. Get this guy soldered. I'm not like I'm good at soldering, I'd say. Like I've done quite a bit. I can always get something to work. It's not gonna be perfect, but I can get it to work. Um, but like I don't get the whole thing about like people being super picky with irons and stuff. Like this is like some cheapo Amazon soldering kit I got probably back in 2021, and I I'm on the same set of tips that I got originally. They've never oxidized, and like I keep care of them, but they're still like they're not super expensive like nice tips necessarily, and they've held up really good. Now I don't want to jinx it because I do want these to continue to last, but yeah, this thing was like $20 maybe, like, and it's worked like so nice. It's actually crazy. Like I don't know if I just hit the jackpot or if I'm missing something here, but this thing has been like totally fine. Okay. Let's see. Maybe. But is there a reason for why the components split across the two boards? Yeah, that's a good question. So basically, let me pull this tape now. So first thing is, oh, wow, that actually looks really cool. First thing is, I do not have a lot of stuff in still. So basically, holy crap, how do I hold this? Remove this guy. Let me get this set up and then I'll answer your question because that is a good question. And then actually, I'll put these back in to show what I'm talking about. So the idea is being able to expand. Obviously, I don't have everything in here. I'm going to be ordering more, but yeah, this is going to be on one like avionics sled in a rocket, so probably about yay long. And basically, the idea is I want to be able to expand like really quick, add and remove components just by pulling them in and out of those those header pins like that. So yeah, I'm gonna add like up here. There's gonna be a magnetometer. There's also gonna be a gyro. I'm not gonna get like crazy into why I'm using those and how they work, unless you are dying to know because it is a long explanation. But yeah, so there's gonna be more components added to this guy, which I haven't gotten in yet. And then down here, the idea is I can stack like. Oh, I need to move this back. All right, I'm done. Whoa. Okay, so like down here, these two slots, I can buy other Adafruit products that are the same shape as the M4 and that have other components on them. So basically it's expanding upon this M4. So I can get one with like a screen if I want to see values, just for like prototyping purposes. I can get one that's got a Wi-Fi chip. There's one with like, I forget, like built-in flash. Like there's a million different ones you can buy. But the point is like I can connect those to here and also have them like all connected to this main processor here, if that makes sense. But yeah, but short answer is expandability. So, yippers. Let's see. Oh, I know what I was gonna do. Let's plug in the massive LiPo. Heck yeah, baby, let's go. we've got, I don't know if you can see, let's zoom in here. We have a power in here. I was right, it was an LED. So that means the barometer is probably good. I don't have any of the I2C lines wired up, but it's getting power. So that's like the first step. But yeah, I think like after the proto board, how do you what's like the first things you like do to get into that PCB, right? So, obviously I haven't actually gotten there yet, but I have a plan in place. So my plan is you can find data sheets for all of these breakout components and this dev board here, this M4, on like what components they used and how everything's connected. Not like obviously this isn't only what I'm going to do, but basically what you can do is literally just quote copy and paste these components onto your board, right? So the capacitors they used on this dev board are optimized for, this power supply and whatnot, like this configuration, right? So using those on my actual board would probably be a good idea because they were used on the dev board and those were optimized by electrical engineers and stuff for this particular application. Now, obviously, I'm going to have to change a few things. I can't exactly use everything, but it helps you get like a good chunk of the meat and potatoes you need, which is cool. So let's see. And for those wondering, there is a SparkFun board with the M4 that has an SD card module built into this area, kind of like what I was talking about. There's kind of a couple reasons why I didn't go with that. One is I already had a lot of components in, so it's kind of like too late. The other reason is I kind of liked anyways being able to see like the physical connections coming out from here for the SPI and how that goes to this versus it already being built in to the dev board and me having to look at schematics for longer than I want. So, but yeah, that's probably one thing I could have done better if I didn't already have components ordered, but it is what it is. And then funny enough, one of my old friends I was talking to recently, we did a project a while ago and we actually made like a Legend of Zelda sword that used a Feather M4, and I forget what the other expansion was. I forget what it was. But yeah, he found this project and he wanted to make it for his sister, and we like soldered this thing for like 2 days. It was a total nightmare. I have a YouTube short about it on my other channel that just showed like it working. But yeah, it was funny because I wanted to remember because I knew he used an Adafruit product, but I didn't remember which one specifically. And he told me the M4. And for my Rocket computer, I was originally going to use the M0 dev board with the Atsom D21. But then I'm like, wait a minute, hold up. I get why I chose the Atsom D21, but his sword has a more powerful processor than my Rocket computer. And okay, don't get me wrong. Like, that processor for that sword is like so ungodly overkill, you have no idea. But like, still, I knew I was eventually going to end up using a processor similar to that for my final production model anyways. So I'm like, all right, I'll switch to it last minute. And the reason I didn't is because this is a 64-pin MPU, and the D21 is a 48-pin, and the 64-pin is quite a bit trickier to integrate in a PCB design. But I'm like, at this point, I'm just kind of like, whatever, we'll figure it out. So, yeah, I don't know. I thought that was funny. Let's see. Cool. Let me get back to this. I want to see if there's an LED on. I don't think there is. Here. Those to me. Let's pull this. Actually, I think I want to pull the. Yeah, there's not, which I kind of knew. Oh, I forget. Oh, I think I read this. Shoot, I'm gonna have to look into this. I'm glad I looked underneath here. So the other thing too about these like proto boards, or breakout boards you can buy, is they do this stuff. They give you options. So underneath, I don't know if you can see with this like garbage camera quality, but these two copper pads here are, I believe, if I remember correctly, what I read are for soldering capacitors too. So I forget if it has to do with like configuring it. Sometimes they do that for configuring it. Like you have to put a capacitor between this and this or something if you're using SPI and this for I squared C. I don't know if it's that or if it's something else. I'll have to read. I'll have to read what the best idea for that is, but I don't think it's like. I don't think it's gonna like. Let me put it this way. I don't think it's going to like. If I don't put anything underneath here for this proto board, I don't think it's like not gonna work as a sensor. But because like obviously they wouldn't sell that, but I don't know. I could be wrong. I need to do some reading into that. Oh, the other cool thing. This is pretty nuts. The reason I chose this accelerometer specifically is this tiny rectangle right here. This little guy right here, the ADXL 375, can handle and record up to plus or minus 200 Gs, which is just like absolutely bonkers to me. For reference, like most commercial accelerometers can only hit like plus or minus 16, which is like still like a crap ton, but yeah, I thought that was like absolutely nuts. And that's kind of the other challenging thing about this stinking project is like literally like obviously I can find like an accelerometer that can handle higher measures, right? Because that's what an accelerometer does. It's like higher acceleration loads, right? But what's tricky is finding other components like, you know, gyros and other stuff that are gonna like not completely shit themselves when I build a rocket that hits like 60 Gs. Which is 60 or 70 Gs is like probably the max I'll ever hit. I don't even think I've seen anyone hit more than 70. But I have seen people launch rockets that experience that much, believe it or not, and not in person, but I've seen videos. So I wanted to build this thing to be able to handle that is what I'm yapping about. So let's finish the power bus on this accelerometer. And I think I might call it after that. We'll see. I was pulling this to see. Okay, I think we're good, chat. I do not see an LED on the SD card module. So that means that there isn't one. Actually, let's pull everything off now because we need to put on our power leads for this guy. So looks like these top two guys are ground and positive. So let's route those guys. And I'm trying to think what else I have. That'll probably be it for today. I kind of want to. I know where I'm gonna put some stuff, but I want to sit back and like thoroughly think through again, like exactly how I want to route all of my lines. Maybe I'll connect the. I think maybe the last thing I'll do is connect the I2C lines to like a common bus along here, and hook up the other sensors to it, and then I can like send some test code to see if those sensors are working after I finish this. But yeah, that's probably all I'm doing for today. Oh, huh. Okay. Yeah, let's finish that up, and I'll call it. So let's see. Red guy. We want to route him from there to there, so it's got to be about yay long. Oops. Yeah, like, so I'm gonna leak this kind of. So this computer is pretty big deal actually for me. So I am eventually planning on, but okay, jeez, I cannot talk right now. The plans for this computer are essentially to have my own flight computer that I can manufacture for cheaper without having to buy like super expensive commercial computers. There are some good ones. There's a company called Silicdyne that just came out with a brand new computer a couple months ago called the Fluctus, and it's really cool. We actually ordered some for our rocketry program at my university, and they are really nice. The UI is amazing. They're just jam-packed with features. They're really tiny, but they're freaking expensive. I think they're like $500 for this board that's like literally as big as this Adafruit board, which is just absolutely bonkers to me. But yeah, I really like it, and you still kind of like want to use commercial computers as like backups. You want to have redundancies because obviously people make mistakes, and say something doesn't work with my computer, I've got another computer or two that's like, oh hey, I think I'm gonna have to kick in here because the main guy is not feeling so hot right now. But yeah, I basically it's a money saver, and also I have some really cool projects planned. I want to be able to do a lot with these computers that commercial computers can't. So I want this to honestly be like an all-in-one computer. So I can do, I can slap this final PCB into like a TVC rocket build. I can throw it into high power. I can pretty much do like whatever I want with it, and not have to build or buy a different computer for like literally every project I do, because believe me, it gets annoying really fast. So yeah. All right, there's that guy. And let's snip these ends here. Can move to like the other guy over here now. Yeah, I wish I printed that damn sled. Or actually, no, that wouldn't have helped because then I wouldn't be able to get underneath it anyways. I'm gonna have to come up with a way that doesn't annoy me though. I'll say that, because like having to take this friggin' wobbly thing out every time is starting to annoy me. So yeah, let's maybe not be dumb. Oh my gosh. Okay, so like I guess I'm like really bad at like cutting wire lengths. Like I either cut these like hella long or they're like way too short, guys. But I don't know. Personally, this is long enough, if you know what I'm saying. Wire? I hardly know her. Please kill me. I really am like losing my mind. It's done. I have no brain. Live streams are just a weird concept to me. Like I don't know. I don't like for sure the pinnacle of multitasking. Talking to people and what are you doing? Luckily I don't have a big channel. All right. Let's see. Let's see. Let me pull this guy underneath here. Is that gonna fit through finally or no? Okay, so I'm just gonna say it like yesterday was a total fever dream. I swear on my life it was. Like I don't so besides like the new Glen launch and me like catting stuff at literally 3 in the morning, like barely alive. Um, it was just so funny watching like everybody in um, Joe Barnard's live stream just actually tweak out over the new Glen launch, and like it was so hilarious. Like I literally got Joe to like do so many funny things. So like I I don't know how many of like I don't know how many people are like familiar with the what the heck's the guy's name? The guy that like goes into Costco and goes like boom. Um, whoever that guy is, I got him to say let's give let's give 5 big booms for new Glen launch, and Joe's like boom. Oh yeah, that it was so funny. Oh, Big Justice. Okay, I had no freaking clue. I couldn't remember. I just knew like it was that little short kid and like the old guy who's like double choke chocolate cookie. But yeah, it was funny. I got him to say like 5 big booms for New Glen, and yeah, that was a great time. And then what else did I get him to do? Oh, so funny enough, people were actually asking him about PCB design and like his board Ava, and he was someone asked like what's the highest Ava ever flew, and he was telling us about one time that it flew like passively into space recently. And so I put in the comments that counts as a space shot because he's been trying to build a space shot for past few months. And he actually kind of got mad about it, and he's like, that does not count as a space shot. And then he like did some other questionable things on that stream. But okay, let's see. Holy crap, guys. I'm going to tweak about as much as I did last night. I'm so glad that I'm like not going to be a surgeon because, oh my God, I probably would have killed like 90 people by now with this terrible precision I have. All right. I'm not about to use side cuts very gently to put a wire in because that would be retarded. Fuck, I can't even get it in there. Yeah, I'm kind of done, guys. I'm done. Like, I've been grinding out like too much. I need to take a break. I think the best like crash out moment I had over this like period, like the past couple weeks, was when I spent like an entire week and a half doing this custom like rocket job for somebody where I was making like nose cones, and I made all these nose cones. It took me like forever to print these, and I have 2 printers. It took me forever to print these, and I finally finished. I was so proud of them. They looked amazing. And then like I texted it to him, And then I'm like, just curious, like, what tube are you putting this in? Are you putting this in like a fiberglass airframe or a cardboard? And he goes, I'm putting it in a 4-inch whatever airframe. And I'm like, oh God, please tell me I didn't do what I just think I did. Surely enough, I catted and printed all of those nose cones for a friggin' 3-inch high power rocket. So I wasted a like good like 2 or 3 friggin' rolls of filament. And it's fine because he actually wanted 3 inches anyway, like 3-inch cones. So he's probably gonna buy them, hopefully, still. Um, but yeah, that really I was about to tweak right there, and that's like I don't usually make dumb mistakes like that. Like I make mistakes, but like that was like really bad right there. Holy crap! I finally got it. Can we get a W in the chat for my pinpoint accuracy? Because I got that the first time. Absolutely. All right. It is time. Yes, W. Oh, wait a second. What did I just do? Oh my friggin' gosh, guys. Hold on. Just as I was talking about how I don't usually make mistakes, I might have just made one. Yep. Okay, that's it. I'm done. I'm done. That's it. Okay, now we're good. Yeah, so like, I don't know about you guys, but I kind of think like the government's watching me, guys. Like, probably like, whoa, this kid is like, Sid. And he's gonna like probably end up killing himself and like the entire world somehow next time he makes a mistake. And he also has a very interesting search history in terms of rocket components because I was never looking at like where to buy trees at like because that'd be preposterous. I would not do that. It turns out that I'm stupid and I didn't need that anyways, and I'm gonna have to figure out some other solution to like, you know, the frickin' FAA like not letting people do stuff. Like, come on, man. I want a rocket, and y'all have to have rules. Like, this is supposed to be land of the free. I do what I want, man. Like, why do I have to listen to rules? It's killing me. It's literally killing me. Oh my gosh. This is driving me nuts here. Let's cut another wire. Okay. This will mark the last ground wire for the sensors I currently have. So if any of you are interested, the way I'm going to eventually integrate these different sensors is it's actually pretty cool. So using an accelerometer, a gyroscope, and a magnetometer combined, which if you don't know what those are, an accelerometer measures acceleration, gyroscope measures position, and an accelerometer measures like magnetic field of the earth, basically, is what the magnetometer does. And like combining all different filtration techniques results in like basically like determining an absolute position of your rocket without GPS, which is something I have to a circumstance ridiculously fast, because believe it or not, the government does not like it when you build things that go fast. Uh, so basically, the rule is, I think, past, what is it, Mach like 2.5 or 1.5, or I don't really know what it is exactly, but past like a certain speed, they basically are like, oh yeah, this guy loses GPS privileges. Reason being is, with those satellites, they know that something's traveling ridiculously fast. They don't know what it is. They just know it's not theirs and it's going fast and it's somewhere in the country. So they stop sending GPS signals from the satellite. So you don't know where the rocket is exactly. Um, so, and then obviously once that speed slows down, which it will eventually, with if you're going that fast, you're gonna get your apogee pretty quickly anyways. So it's not like it's a long blackout period necessarily. It's just kind of like, it's just annoying to deal with, put it that way. Um, but yeah, so that's what you do, or that's one thing you can do. That's not like the only way to find where the rocket is. There's ways you can do it without um, even you. Having those different sensors may come in handy reasons down the road. So, but yeah, that is like bonkers to me. Like a sensor that measures the magnetic field of the Earth, using that to find like the absolute position of something is just a crazy concept to me. Like, I just don't know how you can have such pinpoint accuracy with a technique like that. Adrian, explain our friend route. I wish I could launch my own satellites for GPS. I'm broke. Hi, Swallow. Oh, that's cool. I'm glad you finished your testing. Also, I'm gonna ban you if you say Adrian again. I swear to God. Um. So yeah, basically, just got that ground wire there. We're gonna route this guy down from our accelerometer, and we're gonna bring it to this ground trace here. So let's take this guy here. My bad. Yeah. Yeah, I'm gonna have to pull a Casio there. Yup, you're bad. But yeah, so that's kind of how going fast works with rockets. It's like it's really hard, and it's because they make it hard, and I get it, because it's like they almost like don't want you to like do bad stuff. But oh boy, does it make it really hard for people that want to do not bad stuff. Um, on so many levels. Okay, let's see here. Is this guy gonna make it to that trace, or am I gonna have to cut it even shorter? I think it might make it to that trace. Yeah, proto boards are. Let me also say that proto boards are literally never pretty, so don't expect it to look pretty. I'm trying my best, but I really, it's kind of hard to avoid. Or yeah, let's see. Let's get that guy in. What microcontroller are you using for the prototype? Or are you making your own? Good question. So, I talked about this earlier a little bit. So, one thing you want to do when you're designing your own flight computer is you first want to start with, okay, what do I want? My what are the requirements of my project? What do I want this thing to do? So obviously you're not going to know everything from the start that you want to do. That's almost never going to happen, but you can figure out a good chunk of it. And once you kind of figure that out, you select components, right? So you're going to look for a processor. You're going to look for different IMUs. You're going to look for all these different things. And once you kind of figure those out, you want to look for what are called breakout components that utilize those components you just found, those raw components. And so a breakout component is something like this. So when you buy a sensor online from like an Arduino kit that comes kind of looking something like this with these header pins, they have your components on there as well as other things needed for them to function in kind of like an ideal scenario. So if you look here, all these little like rectangles, like this one right here to the left is a capacitor. These two here are resistors. Down here, we've got resistor, two capacitors. They basically optimized for the sensor. And then from there, when I'm like done with this proto board, I can look at the schematics for these different breakout boards, and I can utilize similar components that are on here. I love the drawing poster. Back to the Future is my favorite trilogy. Yeah, I like Back to the Future as well. I still have to build this thing. I don't know if you've done these before, but these are called Metal Earth kits, and you take these, they're just like little sheets of steel, and you take like there's tools. I have them in my drawer, but there's like special tools, and it's literally just like putting a bunch of tabs in there, and you like bend them or twist them to like have everything hold together. I've done a couple before. I have like one of the Voyager model in my room, which is pretty sweet, and then I have like a biplane, like the Wright brothers biplane. Oh yeah, oh my gosh, I know, they're so fragile too, which is like, it's stressing me out because I don't even like, they get dusty so quickly and they're hard to clean. But yeah, they're fragile because it's like really thin metal. Is that the was that like the one with the launch tower, like the one that's like, I swear I feel like I've seen that one. I don't remember if I know I haven't built it, but I think I know what you're talking about. Yeah, that stinks, man. They take so long too. Yeah, I kind of like them. It's kind of like a fun like side project. Another thing, like, besides high, like, don't get me wrong, like high power is my game for real. I love high power rockets, but you always have to like every now and then venture back to like the smaller guys. And there's a really cool store that kind of remakes vintage kits called like E-Rockets, and their brand is like Semrock, and they remake like Estes kits and other rocket company kits from like the 60s and 70s, and they're really cool because honestly the rockets back then were a lot better than the boring kits from today. And I'll show you what I mean. I'm not just like glorifying the past. It is pretty cool. So this kit here, I bought this. I still have to build it, but this kit here is literally like, it's pretty cool. But this was built in 1974, or originally released in 1974. This is a reproduction. It's not an original, and they make it as close to the original as they can, so it's pretty accurate. And what I thought was cool about it is it's pretty like, it's a pretty unique trick rocket. So you can see up the length of the rocket, you've got this really long like ellipsoid blade looking piece, and when your ejection charge goes off, there's like, I think there's like flaps on the tail that flip down with rubber bands, and then when the charge goes off, what also happens is this whole blade flips around and it turns it into a glider. And I just thought it was a really cool model, and I was like, yep, gotta buy that one. So I like trick rockets. I think they're really fun to watch. And what's also cool is they even went as far as like making everything like close to original as possible by like making balsa nose cones. So everyone today is making blow molded nose cones because they're cheaper and balsa is scarce. But these guys literally like go down to like even making balsa nose cones to like the same ratio, which I think is like pretty neat. But yeah, so that's my that's my rant about doing things for fun and not always being stressed out about like doing hard stuff all the time. All right, what's going on in the chat here? I haven't made any kid. Super Curious Design too. Yeah, a property in Egypt. What? I don't know what the heck you're talking about. So let's go back to what the heck I was doing. Let's get this ground wire on. Okay, where did I put that towel? That should conclude our routing for the current sensors. Obviously, I have more coming. There's a lot that needs done still, because literally I maybe have like a third of the stuff I'm gonna put on here, but yeah, that's kind of like the start. That's where I like to start too with most wiring, is power routing, because I think it's the most important. You've got to make sure nothing's shorting, that you're routing stuff efficiently, and that's where I like to start. I like to start with making sure everything's got nice power routed efficiently, and getting that working, and then I'll move on to like making sure that we've got chip select and SPI and ITC and all that crap figured out. So, but yeah, this guy will look a little bit cleaner when it's done. I'm trying to hide most of the wiring underneath of these pins, so it's just like a nice solid sled. But yeah, this is like, obviously this proto board is going to be like way bigger than the actual like final production PCB. A final production PCB will probably be, if I had to guess, like maybe the size of an Arduino Mega at most. But yeah, so that's where we're at. We want this computer to have capabilities for doing pretty much anything I want it to. And let's do one more quick power check. I thought I knew it. If you're able to keep everything super compact. Yeah, that's another challenging thing, and honestly, it probably will be smaller than that. That's just like that. I don't think it will definitely not be bigger than that when it's done. But yeah, these components are really not that big. Like when you really look at these, like really the only thing that's on this board here is the accelerometer chip and the 6 other pieces, the 3 capacitors and 3 resistors that are on here. Rather than that, all that's happening is the traces from this are getting routed out to all of these header pins, and it takes up a shit ton of space. And they also put like mounting points, so like really you don't have a whole lot of. Basically, what I'm saying is when this is on the final board, the profile of this is only a couple millimeters wide. All the rest of this stuff is not going to really transfer over. So yeah, a lot of this stuff is not as big as you think. However, what kind of makes up for it is like, for rocketry, again, like I talked about redundancies. Another way you can help with using less external computers is by literally like within your computer itself having extra components. So I might and probably will actually end up adding multiple accelerometers on my final production model, so that actually for multiple reasons. One being if, say, one fails or gets fried or whatever, I have a spare that I can refer to in flight and whatnot. And also, having multiple processors, as dumb as it sounds, is actually really cool, because what you can do is not only between like what I mentioned earlier, where I'm going to, you know, combine magnetometer, accelerometer, and gyro values for like really precise filtering, but you can hone that in like so much more by having even more components. So like, and I this is where you can like really delve into like the nerd realm, but having like, for example, having a couple of extra accelerometers, what that can do is, filtering all those values as well into your filter helps eliminate sensor drift and like sensor error. So you get even more accurate readings if you're actually utilizing those extra components as well. And we're talking like really high end precision. Obviously, it's not going to make like a 90% difference, but it does make a big difference. And I'll say this, when you're going to go really fast and really high, tiny little errors add up really fast. So that's why we want to compensate for those, make sure that they don't occur. But yeah, let's see. If you look here, everything's super bad. Yeah, so Dill Pickle. This would basically be like my own Ava computer. I don't know how much you guys have seen about the Ava computer, but it's a good computer, but it is very overcomplicated in some areas and it's flawed in other areas. If you really delve into it, he's got some errors with how he routes his power, and manages his power. It's not the best. Specifically with like buck converter that he used and all that, wasn't the best. And he overcomplicated it a little bit. You have to think with one of the reasons he does that is, you know, A, he wants to make sure it's going to work, but B, when you are a YouTuber with a lot of subscribers and you have to present your work to a large audience, the internet is a mean place and they like to pick on you. And so he likes to really, really overdo stuff, to avoid some of that backlash. But it's a lot of what is on that board isn't completely necessary. There's a lot I agree with and a lot I don't. For example, one thing on that board, one example is that board has 3 main processing units. So it, it's pretty bonkers. So there is an MPU for there's like one processor that's designated to like literally just taking and like handling the raw data from all the sensors, and then from there it like sends it to other processors and stuff, like that filtered down data that is like actually getting used by the rocket. Because you got to think like these sensors, they record quite a bit. They can record, honestly, like all of them together can record a lot faster in some cases than the processor can actually handle, which bogs it down. You can solve that by having a processor with a high clock speed, or the other thing is, think about it, you don't need every tiny bit of data from every fraction of a millisecond coming from these things. You don't need that much precision. Even in rocketry, it's pretty rare that you need values coming in that fast. So what you do is you limit how many packets come in and when they come in. So your processor is not as bogged down, right? So there's ways to work around it, what I'm saying, instead of having like 3 processors. I get why he did it, but oh my God, does it make PCB design and many other things a bitch, and it doesn't need to be that way. But I do respect the design, and I'm still on the fence of whether or not I want to do it. And then I'm trying to think, what was the other one? I think the other processor mainly handles comms, so it'll handle telemetry and comms back to the ground station, which again I think is a little overkill. I don't think you need that. That's how that worked. Let's see what's going on. Yeah, 3. I agree. Is there a data logger in there? It just looks like an SD card. Seriously, this might add weight, but if you added an RTC module and a buzzer, so if you so the first question about the data logger. Again, there's still a ton of components I have coming in the mail, so not everything's on here. The way this first board and sorta kind of how my final board is going to work is you got to, so let me back up and explain why. So for recording data, it gets a little tricky sometimes because you not only do you want like you want your live data, right? You want live telemetry on the ground from your ground station, being able to see like real time what the rocket thinks it's doing or what it is doing. And then obviously with that live telemetry, you don't want to like bog down your radio with like a shit ton of data. So what you would do is some of that more like fine tuning, like nitty gritty data that you don't need real time, that you handle on board. So it keeps that data on board instead of sending all of that back to the ground when you're going, really fast and really high. So how do you handle this data, right? Well, that gets pretty tricky because you got to think with more so with high power applications, but still even with low power, this is a problem. A rocket experiences a lot of vibration, a lot of really kind of rough, just overall, just a rough environment to be in, right? To be a rocket. so this stuff makes a difference on how computers perform, believe it or not. There's some really kind of cool and also really gross science you can get into about like how like these things affect each other in like high power flights and whatnot. But basically what I'm getting at is rocket's going to go through a lot of vibration. It's going to go through a lot of crazy stuff in flight, and relying on a physical data transmission is pretty tricky, because if you're having vibrations in flight and whatnot, you're relying on a physical connection of a TF card inside this mount to be solid. And I guarantee you, no matter what you do, that's never going to happen. You're going to lose packets to this SD card. Not to mention, it's entirely possible, and this has happened, where SD cards will just come out. Like if it's a high G flight or if just some weird thing happens, they can come out. These SD cards, they're not as reliable for high altitude and high vibration and high G load, all those kind of scenarios. It's not something to rely on for live recording high, like really precise data to. So how do we fix that? Well, there's a couple of ways, but the way I'm going to do it is through a flash chip. So I don't know if any of you guys know what a flash chip is, but basically, flash chip can be used to store data. So what you do, and what's also nice about a flash chip is it's like really, it's much faster to write data to it. So I can write much more dense packets to a flash chip than I can to an SD card. So I can send a lot more data a lot quicker to a flash chip and have it record that data on the flash chip. And then when the rocket lands and it's in a stable and safe environment, I can have it transfer that data from the flash chip to the SD card. So that's the plan for that. I could get into it a lot more, but yeah, it gets kind of tricky. You got to think about a lot of these things, and it can be hard sometimes. What was the other question? You said adding weight. Yeah. So again, I have all that stuff. It's not on here yet. There will be like buzzers and LED indicators. I will say, even like the really loud piezo buzzers, say like this, when we're obviously not with this proto board specifically, but with like the final board. Geez, what was I saying? When we're out in the middle of the desert launching this thing, you're not really going to hear a buzzer if you're like miles away from this rocket, because they do drift miles. So, and it drains your battery. So usually you don't rely on a piezo buzzing for like hours at a time to find it. A, because you can't really hear it that well, and B, because it's going to drain your battery, and you want to use that battery to continue outputting that GPS position and like where the rocket's at, and that data that it recorded from flight. You want to get that to your computer so you can find the rocket and figure out what happened to it during flight. If something went wrong, you can figure out where those scrap pieces may have went, where the payload could be. You can troubleshoot, and that's mainly what you want to be able to be doing with your computer when the rocket lands, versus it kind of shutting off. So the rocket is the plan would be to launch it in the desert when I get there. I don't have many components in. I have orders placed, but I have orders placed for the component. Some of the components, I don't have everything. It's going to be really expensive, but yeah, the plan would be to go out in the desert. The waivers out here in the East Coast are just really not that high. So you kind of have to go out west if you're pushing crazy altitudes. And by the time I get to the point where I'm ready for this really, really fast and high flight, it's definitely going to be at least close to the desert. I don't know if it'll be in the Mojave at the far site or if I'll be like closer, or like around that area. I mean, like maybe in like Colorado or like in the Utah Salt Flats. Those are pretty good launch sites as well. But let's see, how big is the rocket? So right now there isn't a finalized design. The general profile we're looking at is about a 4-inch diameter, so about what my last build was for Affinity, and possibly around 8 feet tall. So it'll be pretty big. The difference is, instead of being a 54 millimeter motor, which is what the last one flew on, this one will be a full fiberglass rocket with a minimum diameter, which means that the motor is just barely smaller than the airframe. So we're talking about an engine that is about 4 inches in diameter and possibly 4 feet or 5 feet long, depending on what I choose. So pretty big motor. But yeah, I'm pretty hyped. This is not happening anytime soon. Like, this is still a year or so away. Just with how involved this project is and how expensive it is. But yeah, how much does this cost? Thousands. This is gonna cost me thousands. For CNC parts, I forget who asked CNC stuff. I'm looking into investing in a CNC. There's a couple I want, but I'd rather just have parts like made for me at a machine shop at this point, because I don't want to dump like 6 G's in a CNC machine when I can probably just have somebody make me the part for a couple $100. I'm willing to do that, since for now, eventually I'm gonna get one, but yeah, for now, probably just have someone else fabricate them. Worst case scenario, most likely, I'm probably just gonna end up machining some of them at my university. We have some really nice machinery, and I think that'll be good practice for me, like using some of that like industrial machine shop stuff. Yeah, you know what else is massive? That low taper fade. Boom, boom, boom. Please kill me. That low taper fade. Oh my god, dude. Oh man. So, I guess we'll do another plug test and see. I'm trying to see if I actually hear magic. Okay, guys. It is very possible that I maybe am not actually entirely retarded and that we have good power. So that's good. Man, I probably should whip up a sled for this thing. Let's see. Yeah, I did say it. I did say it. You're gosh dang right. Wink. Lucas, you talk like the average YouTube Shorts comment. How big is that battery? So this battery here, I picked this up from Micro Center today. Um, this is a, believe it or not, this is a single cell LiPo. It's a 2500 milliamp hour, so I wanted it to have plenty of juice for this computer, because another consideration is you got to think when this is sitting on a pad, um, in the desert, like I said, it's not like it's not even like the high power launches I've been to. Oftentimes, there's a lot of stuff going on. There's a lot of launches happening, and your rocket may be sitting in queue, like on the pad, turned on for like hours at a time. So your avionics need to be powered sometimes for like several hours. So you need to have a pretty high milliamp hour battery that's going to be able to keep up with that. But yeah, this is just a single cell. Believe it or not, that is actually probably enough for most of what I'm doing with this computer. Although when I get to the final version, I am probably going to end up using a 2S. But yeah, like, just so you know, literally like 90% of the components on here, actually all of them as of right now, cannot take more than 3.3 volts. So when I put in a 3.7, which is actually a 4.2 volt battery, it actually steps that down to 3.3 to give to all of these guys. So when I put in a 7.2, which I can't right now because it'll fry the buck converter, but when I put in a 7.2 to the final thing, what the 7.2 is for is A, the current to be able to run longer, but B, that voltage and current to be able to light pyro channels and all the stuff that you want to do, and say powering servos and other electronic stuff. That's what that higher voltage is for. It's actually not really for any of the computer components themselves, which is a pretty big misconception. Let's see, volts, amps. I hate the YouTube. Let's use. What if you had some sort of external plug for the avionics just for powering on the ground and lowering the mass? I kind of think I see what you're getting at. So for powering avionics, it's kind of tricky because, like, ideally you would want to power it up right before launch, but like I said about the Q thing, that's kind of a regulation type thing. Like when you go to a launch site that's through NAR or TRA or whatever, they have like rules, and that kind of plays into that. So like, unfortunately, while that would be ideal to like power it on right before you're lifting off, like a minute before, oftentimes they don't let you do that. And this is more for like really high power, which now they're kind of more lax with some of the like lower power in high power, if that makes sense. But yeah, when you get to like high power, they take it seriously. So that's unfortunately one thing. But one thing that I did on my L2 build Affinity, which actually I wish I had back here, but I did screw terminal switches. So instead of having to take the whole avionics bay apart to actually power it up, what I did is there's super small holes drilled in the what's it called? The transition part on the avionics bay. And those holes do two things. They let air samples in for the barometer to be able to read pressure values, and then they also allow for me to get a screw in through the rocket airframe. And what I do to power up the rocket is you literally tighten a screw, it makes contact with a PCB, and that's what powers up the rocket. So you can literally power up your redundant avionics systems with like a couple of screws, and it's really quick. It's really nice. and I kind of like it. But yeah, I sound like FRC. Yeah, it is. If I gave my rocket a low taper fade, I don't know. I don't know. I'll have to think about it. It's like, yeah, poor man's relay. That's pretty funny. Yeah, it's kind of like FRC where there's rules. They get really picky with it for L3 class rockets. They really take it seriously, and there is a whole like set of rules on their website and stuff that you have to follow. And it can be stressful. But yeah. Uh, yeah, I don't know. I need to like besides like Groundbreaker, which honestly did not have a funny name, but was a funny rocket. I need to like I need to do like a fun non-nerd rocket for once, and I really don't know like what to name it because literally I feel like every good idea has been taken already. Like I don't know if you guys follow Joe on Twitter, but he hasn't posted this on YouTube yet. But he built a rocket just for fun, a high power build called Mach 2 that went Mach 2, and it was pretty funny. I thought it was pretty clever. You should code the avionics with Apple II and manually typing in the ones and zeros. I don't hate myself that much, so no. I'm trying to think. What else do I have to do on this thing? Let's see. Gosh, what is the... I'm interested to see what these int 1 and int 2 pinouts are for. I'm going to look up that on the data sheet. Okay, Hawk, Utah. Expected from Joe. 3XL common rocket nose code. Oh my gosh. Okay, that video was genuinely the funniest thing I've ever seen in my life, and it's kind of sad that, but oh my god, that was so funny. I was just, gosh, I don't think I'll ever be able to unsee that. I'm trying to think what the heck, what else is going on here? I'm kind of done making stuff right now. I'm happy where this is at. I know what I'm gonna do, which is kind of awesome. So, yeah, I'm not looking forward to like how many thousands of lines of code that this thing is gonna be, because it's gonna suck. The best whatever. What else can I show? Trying to think. Yeah, the hot glue rocket was actually a pretty impressive build. I'm not gonna lie. Like that was a lot more challenging than I think most people realize. Like, he's flying a freaking hot glue rocket in literally the friggin' desert. So, like, there's problem number one. Problem number two is like, there is so much stuff that goes into a high power rocket like that, and stuff. So like, being able to like actually have those working and like mounted and everything like contained in that freaking rocket is just, it's honestly a nightmare. I still think it was an overkill project though. Like, he did not need to mill out like $400 molds for the airframe, but it was still really cool. Yep, it is the Titanic. Oh yeah, the hot glue rocket is by far probably one of his funnier ones. Yep, that's a good point, Alex. Oh my gosh, this tripod is so bad. Yeah, I did this guy. It's okay. I mean, for what I used, it came out pretty good, but It does sail. I haven't taken it out in a while, but it does work. The plan was I was gonna buy an RC plane and fly like a little plane off the deck, but I never got around to it, so I'll have to definitely do that. Um, and then you can kind of see like it's a little chaotic here right now. I've been really focusing on like not only the computer and like other shit, but also like getting orders out. So I made a partnership recently with a rocketry company, and so I've been printing a ton of inventory to sell my products at, and then also restocking inventory for my own. And then this was the custom job that I did for the one guy. These are high power cones, and these thread together to make like a really cool nose cone. It's like about, I don't know, like 28 inches long or whatever it is. But yeah, they look pretty cool. And I got these really nice sleds that I made for them. It came out, overall, it came out really nice. It was all printed on my Neptune 4 Pro. Um, but yeah, these multicolor print on the A1 Mini came out good. I don't remember where I put it. Try somewhere else. Yeah, this is not that wide. This thing's only like maybe a foot and a half wide. So it would need to be like a small plane. Plus it's a really light boat, so it's got to be light. I also have, what was cool is I also have like a couple of other boats. So I was sailing all of these guys together, so it was a whole fleet. It was pretty sweet. Yeah, it was a destroyer and then a torpedo boat. That's what those guys are. I think a 50-inch plane will fit. Sure. You crashed my dual prop. Oh my gosh. Oh my gosh. That's so cool, but you need to transfer. Oh yeah, absolutely. I cannot even believe, like, that jet is sweet, but like, holy crap, you got to do some practice flying, man. Like, you got to get your stuff tuned in. Now for that plane specifically, I think it would be a lot easier to learn how to fly it, because it is more of a trainer plane. That's what that one's designed for. But that doesn't mean it's still like super easy to fly if you've never flown a plane of that scale before. I yeah, I went to an air show, well, not like a real plane air show, but like a model plane air show up in Lima back in October, and it was pretty sweet. There were guys there with like these $12,000 jets, and they literally went like 220 miles an hour. And what was cool is because it was in the middle of nowhere, there weren't like a bunch of rules and like people making you stand back. So these guys were doing like literal like low passes, like maybe 10 feet in front of you at like 200 plus miles an hour, and it was pretty freaking cool. Yeah, believe it or not, there's like not in Ada where my school's at. There's not a lot going on, but in Lima, there's some cool stuff. It's a club, and guys will come up and fly and do tricks. Like there was one guy, there was one guy who showed up with a carbon fiber helicopter, and this guy is insane. I don't know if have you guys ever seen those videos of like the helicopters like flipping around randomly, and it looks like they're out of control, but they're just like really good pilots. Um, so this guy was doing that stuff, and then everybody totally lost their crap when he flew this thing inverted, and he was cutting the grass with the helicopter upside down. It was like probably one of the cooler things I've seen. Doesn't show high options. Yeah. I don't think I have a hard RC helicopter. I have like a tiny one, but what? Dang. That just seems like a skill issue for real. I don't know what to tell you about that one. That one kind of seems like a little bit of a skill issue there. So From an RC helicopter, I don't know if I believe you. That's like, I mean, I can believe that happens, but holy crap, that's nuts, man. That's terrible. What the heck did I do to my? What? Oh, Nitro was actually pretty sweet. Yeah, I kind of want to try Nitro out. My buddy, actually, Andrew, we were talking about buying a Arma Limitless and like modding the crap out of it and making like a speedrun build. Yep, yep, that'll definitely do it. It's pretty neat. Turbocharged Limitless. Yeah, Limitless is like the ideal. Oh yeah, like your brother Andrew. We talked about this. We were literally talking about like we've talked about this since we were both like, or actually we were never in the same grade. But since I was a freshman, we've talked about buying a Limitless like chassis and like splitting it, like splitting the money for it, I guess, to pay for it, and like mining the crap out of this thing. But yeah, it's a pretty good platform. They're expensive, but most people I've seen without doing a whole lot can get them to hit like 160, 170. So, I mean, you don't have to do a whole lot, but it's expensive to do the little things that you have to do. So, I've always wanted to do it, but it's just like, it's so pricey, and it's like, it's so hard to see those things when you're driving them. Like, even when you've got like a 1/6 scale car, which is a big car, RC car, like, it's still like really hard to see it when it's going that fast and it's that far away. How's it kill these? Like 1/6 scale, as in like dimensions. So like it's a sixth of the size of a real car. Actually, I think the Limitless is actually 8th scale. I could be wrong. Yeah, it's still a pretty deep, like it's a pretty big car. Uh, Guys, I'm like not sure what video I want to make next. I'm like stuck between making a video on my L2 or the 15-foot rocket that I did. That was pretty funny. Like, that is by far like the dumbest project I think I've done ever. Like, I have no idea how that thing would do both. Yeah. Well, it's been a while. The stream's been on for a while, so unless you guys have any other pressing questions about, like, you know, electronics and stuff, because, oh boy, rocket science is like, it's actual rocket science. But, collab, bruh, okay, that's it. Wait, I can read messages. Wait, how do I? Oh my gosh, I can boot you. I'm gonna boot you, Lucas. Yeah, all right. Thanks for joining, folks. I hope you learned something. That was the point, was to learn something and to showcase what's going on here. So, see ya. Nice chatting.